So second derivative just means that you take the first derivative and then take the derivative of that derivative, just like from position to velocity to acceleration, all right? So we're going to take the first derivative here. First derivative is not hard. What's the derivative of x squared?
2x.
2x. What's the derivative of a y squared? 2y dy dx. And what's the derivative of 25? 0. Now, in order to do this, I need to get dy dx by itself. So I'm going to subtract my 2x over. I have 2y dy dx equals negative 2x. Divide by my 2y dy dx equals negative 2x over 2y. Obviously, I can reduce. We get negative x over y. All right? So far, so good? Second derivative requires that I then take the derivative of this guy, okay? So dy dx equals this. I want to find second derivative, which is noted like that, by the way. You see the little 2's on the D? That means second derivative. All right, so finding second derivative means quotient rule, okay? Yes? So derivative of the top. So now I'm doing dy dx again, right? Derivative of the top is just negative 1 times the bottom, that's y. Minus the top, that's negative x, times the derivative of the bottom. What's the derivative of y? 1 dy dx, right? All over the bottom squared, which is y squared, okay? So we're going to simplify this a little bit. We have negative y plus x dy dx, right? All over y squared. All right? Now, what's dy dx?
dy dx is negative x over y.
Negative x over y, right? So I am going to fill that in. Everybody see that? We know what dy dx is, don't we? So if I know what dy dx is, why wouldn't I just fill it in? So I'm going to plug it in. I'm going to replace this guy right here with negative x over y.
X is multiplying that, not...
We're going to say negative y plus x, and instead of dy dx, we're going to write negative x over y, okay? All over y squared. So far, so good. Now, let's do a little just basic algebra up here, okay? We are going to multiply these, right? So we have negative y plus negative x squared over y, all over y squared, okay? I need a common denominator to combine those fractions up there. What is my denominator? Y. So I am going to multiply this top and bottom by y, right? Does that make sense? So I have negative y squared plus negative x squared all over y squared. Everybody see that? I just got a common denominator. I just multiplied top and bottom by y. So this became negative y squared over y minus x squared over y. Yes?
So
I just got a common denominator for my numerator. All right,
now
so
here's the fun part.
So here's what I'm going to do. I'm going to take a negative out of this numerator, negative, and make that, I'm going to put it in order, x squared plus y squared, okay? So far, so good? And when you have a denominator over denominator, you can just multiply your denominators. Because you can if you keep change flip, you're going to end up having y times y squared, so this is y cubed, okay? What's x squared plus y squared? What's x squared plus y squared?
Oh, I would have never got that.
All right, so
25.
I can replace this guy with what?
That would be 25.
With 25. Negative 25 over y cubed is my second derivative. All right, find the tangent line to the graph. If you're trying to find the tangent line to the graph, then you have to find the derivative and then plug it in to get your slope, and then use y equals mx plus b, right? We have to get our slope intercept. So I personally would probably just distribute that x squared through. So I would say like x to the 4th plus x squared y squared equals y squared. Like I would do something like that. And then do my derivative. So I would have 4x cubed. And then, of course, this requires the product rule. This is not asking for second derivative, by the way. This is just asking for the tangent, you know, the graph of the tangent line. So move your dy dx's to one side. Move your non-dy dx's to the other side. And then divide. All right. This is first derivative. In fact, you don't even have to worry about simplifying it at this point. I don't think you can, because you already have a point to plug in. Granted, a hideously ugly point, but a point number that nonetheless to plug in. If you plug it in, you get your slope. And then you're just going to put it in y equals mx plus b using this point that they gave you. So plug in your xy to find your slope, and then use your x, y, and slope to find your equation. Right? And you can use that equation, or you can use, you know, the point slope if you want to use that. Right? So plug in xy to find your slope, and then use your point and your slope to find your line.